Okay, just going to look at integrating inverse trig functions. So I'll just run through a few of the rules. If you go into the formula sheet, you'll see this. F dash x over a squared minus f of x squared dx. So that one's the sine the minus 1 function. You also notice on the formula sheet there is no cos the minus 1. If for some reason there was a negative there, or for some reason it was a multiple choice, there's an extra negative here for the sine the minus 1. So if you had to get a cos the minus 1 because somehow it was in the formula sheet, then you could do that by just sticking a negative in there and counteracting it by putting it on the outside. Okay, and the third one is a tan the minus 1. So it's f dash x over a squared plus f of x squared dx. So that has a 1 on a because there needs to be an extra a here which is counteracted. So on the formula sheet that's why there's a 1 on a there. And then tan the minus 1 of f of x on a plus c. So we'll just run through integrating a few of these. I'll do one of each type. So the integral of, say, 7 over the square root of 9 minus 25x squared dx. Integral of 3 over 9 plus 16x squared. Might actually take the 3 off and make it something else that's really unrelated. We'll do 7 again. And then the integral of minus 5 over the square root of 3 minus 4x squared dx. Okay, so looking at the first one, the first thing you do is you pull the 7 out. You notice that you can't, like if you look at f dash x of just 25 minus 25x, 9 minus 25x squared, that would be your f of x. Derivative of that is minus 50x. So because there's no x's on the top, that's why you know it's an inverse trig function and it's a sine the minus 1. So take the 7 out, and so that'll be 3 squared minus 5x squared. So that's just setting it up into the form of your formula. So that's like your function, the f of x, and this is your a. The a is 3. So f dash x will equal 5, because the derivative of 5x is 5. So that means on top you have 5, on the bottom here you have 5. So it's 7 on 5, sine the minus 1 of f of x. Now the f of x is just your 5x on your a, which is your 3, and then it's plus c. Okay, let's look at this one. This one's a tan the minus 1, because once again, the derivative of 9 plus 16x squared is 32x. And you can't create an x on top because it's not there. So take the 7 out, and it's just a 1 on top. So 9 plus 16x squared. So let's set it up into the right form. So it's 7, 1 on 3 squared plus 4 of x squared. So the a is equal to 3, the f of x is equal to 4x, f dash x is 4. That means on the top here, there should be a 4, but there isn't, so we put it in and we divide by 4. There really should be there too the extra a. The extra a is a 3, so that's why that'll be divided by 3. You notice the 1 on a is just put directly into your formula sheet. So it's 7/12 tan the minus 1, because that thing on the bottom we're dividing by is 3 times the 4. Tan the minus 1 of f of x, which is the 4x, on the a, which is the 3, and then plus c. Okay, so this one has a minus, so we're just going to do it as a cos the minus 1. So take the 5 out, so it's minus 1 on root. Now that's 3 is just root 3 squared. 4x is 2x squared dx. So it's going to be 5. Now, if you look at the derivative of f of x, it's 2. So that should be 2 and 2. So it's 5 on 2, cos the minus 1 of f of x, which is 2x, over root 3, and then plus c. Okay, so I'm just going to do a couple of definite integrals on this stuff. You just got to be careful when you're evaluating inverse functions you know, like for example, sine the minus 1 of 1, that's 90. But make sure that you write your answer in radians. So your calculator might give you the 90, but always make sure you change it to radians. Okay, so let's do a definite integral. So we're going to go 1 over the square root of 25 minus 9x squared. We're going to do that up to do it up to 5 on 3. Okay, so rewrite it. So it's 0 to 5 on 3 of 1 over the square root of 5 squared minus 3x squared dx. The derivative of the 3x is just 3. Divide by the 3, so you just go 1 on 3. So you go 1 on 3. Now that's going to be a sine the minus 1 of f of x. The f of x is the 3x over a, which is 5. Now we're going to go from 0 to 5 on 3. So we just have to substitute that in. So it's 1/3 sine the minus 1 of 3 on 5 times 5 on 3 minus sine the minus 1 of just 0. So it's 1/3 sine the minus 1 of 1 minus sine the minus 1 of 0 is just 0. So sine the minus 1 of 1 is 90, so that's pi on 2 minus 0. So you end up with pi on 6. And I'll just do another one. This one can be a tan the minus 1. So you go 4 on 16. Actually, I don't want to put one that matches. I want you to think about what should be there. We'll go 9 plus 3x squared dx. Okay, so can't create the f dash x, so therefore it's not a log. Take the 9 out, so you get 1 on 16 plus 3x squared dx is 9. 1 on 4 squared plus, oh, it's not 3x squared, sorry, it's not 9x squared, it's 3 plus 3, so it's root 3x squared dx. So the function is root 3x. I want to do this with the endpoints as well. Okay, so it's going to be, we'll go from 0, and it's going to go from 0 up to 1 on root 3. And so let's make it, because it's going to be, yep, that'll be right. No, because it'll be a tan. So I'll just get a better number in there. So let's make that a half, or 2. If I make it 2, it's going to be that on, so it'll be root 3 and x on 4. Yeah, so if I make it 2, make it 4 on root 3, and then it'll cancel out and be a bit nicer. Okay, so let's go. So the derivative of root 3x is root 3, so you put root 3 in there and root 3 in there. There should technically be the a, because the a is equal to 4. The f dash is root 3. So there isn't, so I divide by 4. So it's 9 on 4 root 3, tan the minus 1 of root 3x on 4, and we're going from 0 to 4 on root 3. So it's 9 on 4 root 3, tan the minus 1 of root 3 on 4, 4 on root 3, minus tan the minus 1 of 0. So that ends up being, I'm just going to rationalise this part. That's going to be, I'll bring it down here, that's going to be 9 root 3 on 4 times 3, which is 12. And that's going to be tan the minus 1 of 1 minus 0, which is 3 root 3 on 4. Tan the minus 1 is pi on 4. So it's 3 root 3 on pi on 16. That's it.